So U on F is equal to 1 plus U on V. We just established that U on V is equal to 1 over M. So I'm going to substitute 1 over M in place of U on V. Irene, are you okay? Irene will not mind me. Oh.
No, please.
Okay, so I need to make 1 on M the subject. So Hilda, what do I do to make 1 on M the subject here?
And you send the 1 to the other side, making it U on F minus 1 is equal to 1 on M.
Thank you. So 1 on M will therefore be equal to U on F minus 1. And that is what we were given to prove. So we've been able to prove that, yes, M is related to F by this equation as we were given. So simple. So Irene just joined us. So let's go through it quickly. The attendance, I'm not happy about it at all. So Adwa, Deborah, Hilda, Irene, and Nanadwa. Nanadwa, are you there? Nanadwa, the toy is here. I saw all you Zoom. Okay,
Mr.
so
Ejim.
I've called you over and over. So we are to prove that 1 on M is equal to U over F minus 1. This is what the question requires that we prove. Okay, where U is the object distance, M is the magnification, and F is the focal length of the mirror. And we are doing this using the mirror formula. Okay, now, what is linear magnification? Irene, what is linear magnification M? This is equal to
V over U.
so this is M is V over U. But in a question given to us, we're given 1 over M. So it means that 1 over M from the linear magnification formula would be equal to U over V. Okay. So we are going to manipulate the mirror formula so that we'll have U over V. If you're able to get that, then we can substitute into it 1 over M. That's all that we are going to do. So to have U over V in this, Hilda, what do we do? In order to have U over V in the equation, in the mirror formula, what do we do? Hilda, what do we do? Let's be quick. Let's be quick in our response.
I'm thinking about.
Oh, to have U over V in the mirror formula, what will you do? Adwa, Nanadwa, what do we do to have U over V in the mirror formula? Nanadwa. Oh. when we are wasting, Deborah, take over. What do we do to have U over V in the mirror formula?
Mr. Via, please.
Quick.
I think for me, I'll add the left side. Like I'll find the LCM to be UV.
Don't
Then
add
I'll
anything.
Hey.
Don't add anything. You have this 1 over F is equal to 1 over U plus 1 over V. And we want to substitute into the formula one. Keep quiet and listen. Okay. We want to substitute 1 over M, which is equal to U over V, into the formula. So what will you do to this to have U over V within the formula? But then go ahead. Deborah, go ahead.
Mr. Via, please, you multiply through by U.
Exactly. So there are some things, I mean, look at it and then, okay, adding LCM is a waste of time. So what you do is that you multiply through by U at both sides of the equation. Okay, so you have U over F here. Then when you multiply through by U, you have U on U plus U on V. Now, since 1 over M is equal to U over V, in place of this, Irene, what can you substitute? In place of this, what can you substitute? Hey. Okay. So I have U over F is equal to 1 plus 1 over M. The proof is that you are to make 1 over M the subject. So make 1 over M the subject over here. So you have 1 over M is equal to U over F minus 1. And you have proven it. Deborah, do you see it?
Yes, please.
No, don't go and add a else here. Open your eyes. Next time, adopt my trick. Okay. Then the other question, which surprisingly, there's a sub question most of you couldn't get. Elder, are you done writing?
Yes, please.
Okay. Be alert. I can throw questions at you anytime, so be alert. Okay.
Okay, please.
Irene, are you there?
Yes, please.
Oh boy, so good. Figure 3.0 illustrates a ray of light incident on one face of an equilateral triangular prism. So we have an equilateral triangular prism. A, B, C. 60 degrees, 60 degrees, 60 degrees. Then there's a normal. This is another normal. Let me increase this a little bit. This is the incident ray. is refracted and is refracted once more. This is normal, so 30. This is R1. R1. This is R2. Then this is E. Okay. Adwa, Akofala, Deborah, Helda, Irene. Nanadra is gone. Akofala, you are welcome.
Thank you, Mr. Edia.
No, you are late. Late, Akofala. So it's an equilateral, so 60. 60. Now our question is that study the illustration and calculate R1. R1, R2, then E. When the refractive index of the prism is 1.5. And the kind of questions I give you, marvelous. You see, the kind of questions I give you under refraction of light in triangular prism, frankly speaking, when you get this kind of questions, you should cruise through it easily. Marvelous. The kind of questions you solve, we solve under this. When you get this, you must solve this so easily. And you see, when I looked at the solutions some of you sent to me, I realized some of you were confusing yourselves with minimum deviation. Are you girls there? Are you there?
Yes, please.
Some of you were confusing yourselves with minimum deviation. But looking at the question, there is no statement about minimum deviation. If you want to listen to it well, listen. It said figure 3.0 illustrates a ray of light incident on one face of an equilateral triangular prism. Study the illustration and calculate R1, R2, E, and when the refractive index of the prism is equal to 1.5. There is no statement of minimum deviation for you to use the minimum deviation formula. There's nothing like the ray passes through the prism symmetrically for you to state that then R1 is equal to R2. And so I was surprised some of you were using the condition of minimum deviation. So those of you who do that, please, I mean, next time when you are giving questions, watch well, okay? All right. How do I find R1? Marvelous, are you there?
Yes, please.
Marvelous, how would you find R1? We are to determine R1. How would you find R1? If you delay, it means You have to, it means you have to think through before you answer. And I won't allow that. Marvelous, do I
So the
continue?
angle is 30 degrees.
Pardon?
It's 30, like, should I say the answer?
No, I want the procedure. How would you find R1? Do I take over? Time's sake. Alright? Okay, I've taken over. Now, the incident ray is from air to glass. And so using Snell's law, the refractive index of the glass prism will be equal to the sine of the angle of incidence sine I over the sine of the angle of refraction at the plane. This is at the plane AB or BA. So we have the refractive index of the prism given to us as 1.5. So 1.5 is equal to sine of I, which is 30, over sine of R1. Hilda, are you there, Irene?
Yes.
So because you are looking for R1, we make sine R1 the subject. And this will be equal to sine of 30 over 1.5. And sine 30 is equal to 0.5. So R1 will be equal to the sine inverse of 0.5 on 1.5. Marvela, what did you get for R1? Akovala, what did you get for R1?
19.47 degrees.
19.47 degrees. So that is R1. Then R2. R2. Irene.
Yes, yes.
Tell us how we can find R2. How do we find R2? Irene, time wasting. I can't wait for it. Adwa Amponsa,
Yeah.
how would you find R2?
Yeah, please. You know that A is equal to R1 plus R2. And since
So
you know A,
okay, so Adwa wants us to use the relation that the angle of the prism A, is equal to R1 plus R2. And since we know A, we found R1, we can find R2. Okay. Irene, are you okay?
Yes.
Eh?
Yes, please.
So R2 is equal to A minus R1. A is 60 minus R1 is 19.47. Therefore, R2 is equal to, yes, Akofala, what is R2?
40.53 degrees.
40.53. There's another way to determine R2 without using A is equal to R1 plus R2. Brittany, tell us. How, Brittany, are you there? Hey, Brittany is gone. Oh, Akofala.
We said, yeah.
How do we use a different, what other different method can we use to find R2? Deborah, I
We said,
hope you're also there.
Yes, please.
What other
yeah.
way?
I'd like to
Mhm.
think it through.
Pardon?
I'd like to think about it. I don't know, David.
Deborah, do you know it?
Mr. Dia, please, I think like you use co-interior angles because 60 is equal to that X form over there.
Me pacho me ye hello ma. Pacho me ye online for WhatsApp me why? Okay. Hey, Deborah.
I say I think we can use a hey,
Yeah,
Mr.
yeah,
Dia is fine.
it's okay. If you recall, we learned that what is the product of this angle and this angle? The summation of this and this. The angle here plus the angle here sums up to what? Oh, are you girls there?
180.
180. We said that this plus this equal 180, and this plus this is also equal to 180. So if this is 60, then this will be, if this is 60, what will be this angle?
120.
So this will be 120. And so if this is 120, and you know R1, can't you find R2?
Yes, please.
Yes, that's the other way to use. Eh? So if this is, we found R1, this is 120, we can easily find R2. So it's like R1 plus R2 plus 120 must be equal to 180 degrees. Okay, R1 is 19.47 plus R2 plus 120 is equal to 180. So let's sum this up. 19 and 120. Akovala, what is 19 plus 120? Akovala,
39.47.
139.47. So that R2 will be 180 minus 139.47. And Hilda, what's the results? Hilda, what's 180 minus 139.47?
40.53.
Exactly. So this is the other way out. Okay. Now, back to E. I'm checking attendance. Marvelous.
Mr. Dia.
You have to tighten your connection.
Yes.
How do we find E? Here, the question is that, you see, Adwan Ponsa, what is this angle? What's the name for this angle? Adwa. Hey, Adwa know where he. Marvelous. What's the name for this angle? Hey, marvelous. But she was just here. Okay. Hilda. Hilda.
Mr. Ejia.
What name do we give to this angle?
Mr. Ejia, please, I have no idea.
You know. Hilda, what is the name of this angle? The angle 30 degrees. What's the name?
Mr.
Angle of what?
Ejia, I don't know.
This is the angle of incidence. You've forgotten. This is the angle of incidence. This is the angle of refraction with respect to AB. This is the second angle of refraction with respect to AC. And so what will be the name of this angle? Irene, what's the name of this angle? Deborah, what's the name of this angle?
Please, isn't it the angle of refraction of the second one?
Are you answering a question or asking a question?
Oh, sorry. Okay, sorry. Is the angle of refraction for the second?
No, that is R2. That is R2. What you are talking about is R2. What's the name of this angle?
I don't know how to call it. The second.
You know, you've forgotten. Akofala, what's the name of this angle?
Angle of emergence.
Angle of emergence. Deborah, don't you know this?
Mr. D, I thought that was you.
E is like the Granson angle. E is like Granson angle. But this is the angle of emergence. Okay, which we often represent by the letter E. It is just that the E is this time given to the Granson angle. But this is the angle of emergence because this ray is called the emergent ray. Emergent ray. And the angle between the normal and then the emergent ray is the angle of emergence. And that angle is measured from the normal to it. So let's determine this. When you determine this, you can find this. Adwan Ponsa. Okay. Are you okay? How do I determine the angle of emergence? You can consider the ray from the glass coming out or reverse the path of the ray from air entering into the glass. Both would work. If you want to use the ray coming from the glass and coming out, then here the refractive index will be from glass to air. Okay, and this R2 becomes, because you are moving from glass to air, R2 becomes the angle of incidence with respect to AC. So this is sine of R2 over sine of E. Here, okay, to distinguish this E from this, let's represent this by X. So this becomes the angle of refraction. Please, are you with me? Hilda, are you with me?
Yes, please.
Irene, are you with me?
Yes, please.
Who else has joined us? Brittany Battles. Her line is not a. Nanado, are you there? Marvelous.
Yes, please.
Okay. Now,
Yes.
what we were given the refractive index of the glass block, absolute, which is 1.5. But we know that this is from air to glass. So if you are looking for the refractive index from glass to air, then it's 1 over 1.5. Okay. As for these basics, we know. Okay, so the refractive index from glass to air is 1 over 1.5 is equal to sine of R2. We found it. R2 is 40.53 over sine of X. X is our angle of emergence. So let's quickly find X. When we make sine X the subject, we have 1.5 times sine of 40.53. Hilda, help me get this product. 1.5 times the sine of 40.53. The rest of you must also calculate, please.
Mr. J, 0.9747.
Okay. So help me find X, where X is equal to, yes, X will be the sine inverse of 0.9747. So give me the exact value.
Mr. Japi says 77.08.
77.08 degrees. Now, Adua Bonsa, Adua, are you there? Adua, are you there?
Yes, please.
What is this whole angle? What is this whole angle from the normal to the glass? What's the value? What's the value
I
of this
can't
whole?
see the image well.
I said, what is this whole angle from the normal to the glass? What is this whole angle? From the normal to the glass prism. What's that angle? Adwa, once you are delaying, it means you are not so clear. Marvelous, what's this whole angle from the normal to the glass prism?
Mr. J, is it the angle of refraction?
Maybe this is the normal, the angle from the normal to the glass prism.
Mr. Japi, please, is it 90 degrees?
It's 90. The normal is always perpendicular to the surface. And that's why we call it as the normal. Because it's perpendicular, that's why we call it as the normal. Marvelous. So once this is 90, and you found this X to be 77.08, Adwa, what will be this angle? What will be E?
13.022.
So 90 minus 77.08. And you go what? Is that what?
13.022.
13.022. That's it.
Mr. J is 9. It's 12 rather.
90 minus 77.08. You had 12.
12.9.
Okay, so 12 points. Approximately, okay, it's close to, you can approximate it to 13. So, and that's it. All right. So the only thing is that you know this to be E, but the E was given to this. So all that you need to do is that find the angle of emergence, then subtract it from that from 90, and that you get the value of E. Now, if you want to determine the value of X, when you reverse the path of the line, this is how it is. We want to determine the angle of emergence when we assume the light to be entering from air to glass. So once the part of the light is from air to glass, we will still talk about the absolute refractive index of this glass, which will be sine of, here, this becomes the angle of incidence, x, over sine of the angle of refraction would be R2. And so the refractive index air to glass, so still 1.5 is equal to sine of x over sine of R2, which we found to be 40.53. Therefore, sine x is 1.5 times sine 40.53. And x would give us the same value as 77.08. Hilda, confirm it for us. Hilda, Wada.
Yeah.
I asked you to confirm it for us.
Yes, please.
So that's it. And so once you found x, you can easily find e. All right. So Adwa, that's the question you couldn't. Now, I gave you, Deborah, are you okay with it? Eh?
Yes, please.
Let's solve the one I gave in your end of in your mock 1 on the same triangular prism. On the same triangular prism question. Please, this is NOVDEC 2023, which was written about 2-3 days ago. NOVDEC 2023. In your what is the question? Sure. Okay. Is that the refracting angle of a glass prism is 30 degrees? Please, do I clean the board?
Yes, please.
The refracting angle of a glass prism is 30. So A we are told is equal to 30. A ray is incident onto one of the faces perpendicular to it. So let's draw our triangular prism. We are told A is 30. The angle of the prism is 30. So A, B, C. And a ray of light is incident perpendicularly to it. So if this is our normal, the incident ray is just along the normal. And the incident ray makes an angle of 90 with the plane AC. Find the angle of deviation between the incident ray and the ray that leaves the prism. Okay, so when the ray incidents on the prism in this manner, it goes undeviated. But when it hits BC, because it is not hitting BC at 90, it will be deviated. Okay. But how will it be deviated? The ray is coming out of the prism from glass to air. So it is deviated away from the normal. So this gives us the angle of emergence E. This is the second angle of refraction R2. Okay. So the question is that we are to find the angle of deviation between the incident ray and the ray that leaves the prism. So the angle of deviation between this and then this. Okay. Now, we know that for a ray hitting the plane at any angle of incidence, when it's not perpendicular, it will refract in this manner. The ray refracts in this manner. And the total deviation, which we represent as this, is equal to I plus E minus A. This is the formula we derive for total deviation. Okay. But this is when the ray hits the this plane at an angle I. Over here, I is 0. And when I is 0, okay, the ray goes undeviated within the prism. But when it hits the other plane, then it will be deviated. Please, I hope you are following. Okay, so this is what we are going to use to calculate for the angle of deviation, okay, between the incident ray and then the ray that emerges, leaves the prism. All right. Now, one thing we have to understand is that when I is equal to 0, R1 is also equal to 0. The reason is that if the angle of incident is 0, the ray never gets deviated. So it will go undeviated. So because it is not deviating at AB, R1 will not be there. Okay. If R1 is equal to 0, then using A is equal to R1 plus R2, then it means R2 will be equal to A minus R1. Meanwhile, R1 is 0, so simply R2 is equal to A, which is equal to 30 degrees. So this R2 is equal to 30 degrees. If you have any question, ask so I can continue. If you understand, then I continue. Okay, so R2 is equal to 30. Okay, so we have over here the total deviation. I is 0, so we have E minus A. A we know. We are left with determining E to find the total deviation which will occur when the ray is leaving the prism. Okay, how do we find E? Two ways. If you are using the ray moving from glass to air, then we use the refractive index from glass to air, which will certainly be equal to sine of R2 over sine of E. In the question, we're given the refractive index of this, which is 1.5. So once the ray is from glass to air, then it will be 1 over the absolute refractive index, 1.5, equal to sine of R2, which is 30, over sine of the angle of emergence E. So we make sine E the subject, Hilda, calculate E for me. Hilda, are you there?
Mr. Chia, 0.75.
So what is E? What is E?
48.59.
48.59 degrees. So once we found E, we can easily find the deviation that as the ray leaves the prism. Therefore, the deviation is equal to E, which is 48.59 minus A, which is 30. And so this is equal to 18.59 degrees. That is the answer. I hope we are all okay with the solution. Are we okay?
Mr. Adria,
Hello.
please, what is the marks for this question alone?
Oh, it's part of a major question under part 2. So the whole marks there is, I think, 15. But this is part of maybe 1 or 2 of those questions.
So, like, how many marks will it carry?
Oh, the marks will be distributed. Okay, the first question talks about define the term accommodation. So this will take about 2. Then explain why a hypermetropic person will not require the use of corrective lens. This will also maybe take about 2, 3. Then the rest will be given to this.
Okay, Mr. Adria.
Why? Why do you ask?
No, I just made a mistake with this one.
Okay. Then any other question? Please, if you have any other question, quickly ask before I clean the board. Next time, I think I'll load the part 2. I did not load this one. Marvelous. Marvelous.
Mr. Adria.
What is the near point?
Mr. Adria.
Differentiate between the near point and the far point of the human eye. Differentiate between the near point and the far point of the human eye. Marvelous. I'm marvelously waiting for you.
Mr.
Go ahead. Hey, you are quiet too. Brittany, are you there? BB. BB is gone. Hey. Deborah.
Mr. Adria.
Deborah is a question for me. What's the difference between the far point, the near point, and the far point of the eye?
Please, you said difference between near point and far point.
Or distinguish between the near point and the far point.
Please, near point is the closest point the eye can see without strain. Without strain.
Without, I won't take without straining.
straight.
Nanajo, okay, that one, let somebody else also talk, say something. Nanajua, what will you say about the near point?
The
Nanajua,
near point is the closest distance to the eye, where the eye can see images or objects clearly.
well, the same, almost around the same. Explain. You are explaining, so you have to give us detail, some enough or detailed information.
And the near point of every human eye is 25 centimeters.
I won't take it. The near point for every human eye. I won't take that. Okay, let me solicit views. So Akofala, if you have something you can add. Hilda, you can also add.
Mr.
Adwa, you too.
Mr.
Mhm.
The near point is the closest point at which the eye focuses objects clearly onto the retina. And then for
Good.
a normal eye, it is 25 centimeters. And it's also called the least distance
Of this thing.
of a distant vision.
Wow. So Nanajwa, you can't say the least distance, the near point for every eye. For normal average eye, for a normal eye, the average distance we call as the near point is 25 centimeter. Nanajwa, you okay? For normal eye, the near point is averagely around 25 centimeter. Okay, and it is, he said it is the minimum or the closest distance where the eye can clearly see, or the eye can focus image of an object onto the retina. And this is also known as the least distance of distinct vision, LDDV. The near point is also known as the least distance of distinct vision. Okay. Beyond this distance, the eye cannot see clearly. Then, Akofala, what is the far point of the human eye?
The far point of the human eye is the greatest distance for which the lens of an eye can focus light onto the retina.
Without straining the eye. When the eye is taking images from an object afar, it doesn't go through accommodation. Okay, and what is accommodation? Is the expansion and contraction of the eye lens by the ciliary muscles in order to bring objects, okay, to a focus. When the eye is watching an object afar, it doesn't go through accommodation. So it is anone related without straining the eye. And the averagely, the near point, the far point of a normal eye is close to infinity. Please, are you picking the details out of the information? Averagely, the far point of a normal eye is close to infinity. So it is the farthest or maximum distance where the eye can perceive images from objects without going through accommodation. Okay, the far point of an average normal eye is close to infinity. Nanadra, are you fine? Marvelous.
Yes.
Marvelous. Oh, she's gone.
Yes.
Akovala, ask, go ahead.
Miss Lydia, please, when we are differentiating, see, you asked us to add like more information to what you are explaining now. Does it
Come
mean that
again.
when we are differentiating, we should do this well?
Come again.
Miss Lydia, please, I would like to know if, for instance, after we define what a near point is, maybe we should add more information like for the normal eye it's supposed to be 25 before we say on the other hand the far point is, then we'll define it, then we'll add more information.
You see,
Is it
for differentiating you, it's like you give detailed information about one and use linking words, linking phrases such as whereas, while, this is, okay. So after telling us stuffs about the near point, blah blah blah, the detail, whilst, okay, the far point, okay, is the farthest distance where the eye can perceive images from a distant object without straining or going through accommodation. Okay, averagely, the far point of
yes,
the normal eye is close to infinity. So it's just the details of each one of them, but you use linking words or phrases to put them together. All
okay,
right.
but then Miss Lydia, please, for definitions as well, should we pardon, yes please.
You were asking
Miss Lydia,
something.
please, I also wanted to be sure about definitions.
Oh,
For
definitions.
definitions, we just say yes please about definitions.
Definitions, you don't go deeper. Okay. You tell us what this is. And then, you see, the difference between define and explain questions, okay, that with definitions, after telling you all that, okay, oh, define this, it says this, blah, 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 blah. Now, when it comes to explain, we need adequate information. So, with explanation, if there are if diagrams and all that, you use that to buttress your point. Example, what is total internal reflection? Oh, blah, 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 blah. I state the conditions, okay? The phenomenon whereby when light moves from a denser medium to a less dense medium and the angle of incidence in the denser medium is greater than the vertical angle of the material, the incident light is completely reflected within the denser medium. That's it. Here, I've given you the conditions. Okay, that light must move from denser medium to a less dense medium. I've also given you that the angle of incidence in the denser medium must be greater than the vertical angle of the material. And when this happens, yes, if I'm to explain, I'll say all this and then buttress it with a diagram. Are you okay? But
Yes please.
in definition, and then what is? The expectation isn't so much, but to explain, you are expected to do a lot. Provide adequate information to buttress your point. Okay. All right.
Yes please.
Now, a luminous object and a screen are kept at a distance of 120 centimeters apart. I think we'll solve this question and end our meeting today. You may be tired. I can see Akofala went for church service and jumped all over, so she's tired. Likewise, Helda. So, a luminous object and a screen are kept at a distance of 120 centimeters apart. Apart a convex length between, oh, okay, so apart. So we have a luminous object. Our old friend Ray box. This is a ray box, and then a screen is here. Then a lens is placed in between them. A convex lens is placed in between them. So a lens is placed between the objects and the screen. So this is the screen. This is the screen. This is the objects, the luminous objects. Luminous because it can supply its own source of light. Now, lines between the object and the screen forms real images at two different positions, okay, separated by 15 centimeters. So all that they are telling us is that when the convex lens is placed between the object and the screen, there are two positions where a real image is formed on the screen. So the displacement between the lenses for the formation of clear image D, we are given as 15. So the displacement is 15 between the lenses, meaning when the object is here, a clear image will be formed here. When the lens is here, a clear image will be formed here. When it is brought here, a clear image will be formed as well. And the distance between the luminous objects and the screen, we are told is 120 centimeters. Okay. Now the first question is that calculate the power of the lens. Are we there? Are we there?
Yes, please.
Calculate the power of the lens. Power of a lens, P, power is given by 1 over the focal length. So it simply implies that when we are able to find the focal length of the lens, we can find the power. Okay. We went through this. I derived the relation, okay, with you, how to find the focal length using the method of displacement. And that's how we did that. We represented the distance between the illuminated object and this as D. Then, assuming this is the first position of the lens where a clear image, a real image is formed on the screen, U. Then it implies that this is the image distance V. Okay, so over here, we are deducing that then D is equal to U plus V. Okay, now, because this distance is fixed, it means if this is maybe 30, this will also be 70. Okay, if we assume that from here to here is 30 and the whole distance is 100, then from this point to this point will be 70. Now, if we displace this, push it, and then the new position is this. And so from here to here, if it's from here to here is 70, then from this point to this point will be 30 if D is 100. And so we could conclude that if this is from here to here is U, then this side would also be U. Okay, where the distance between them is D. All right. All that we are saying is that, oh, okay, then this if this is U, this will be V. From here to here will be V. 30, 70. Okay, 30, 70. 70, 30. So we are representing this way. So if I'm to find D, then I can say that D is equal to, when I subtract, because this is V minus U. And earlier, we saw D to be equal to U plus V. Please, are you following with the two different equations? Earlier, we saw that if this is U, this will be V. So D is equal to U plus V. Now we are saying that if this is U, this will be V. And this is also U. So their displacement can be equal to subtracting this, or yes, this from V. So D is equal to V minus U. Okay. Then we added equation 1 and 2. So equation 1 plus equation 2 gives us D plus small d equal to 2V. And V is equal to D plus small d all over 2. Please, are you with me? Are you with me? Can I continue?
Yes, please.
Okay. Now, when we subtract equation 1 from equation 2, so equation 2 minus equation 1, we also have D minus small d giving us, we are subtracting this from this. So V minus V, 0. Okay. U minus U would give us 2U. Therefore, U is equal to D minus small d all on 2. Okay. Having had our formula or values for U and V, we substitute this into the lines formula. And this is what you learn. As for the proving, fine, if you understand it, it's a feather in your cap. So 1 on U is D minus small d on 2 plus 1 on V. V is D plus small d on 2. So we have 1 on F giving us 2 on D minus small d plus 2 on D plus this. We simplify this. Okay, maybe LCM, Deborah, your favorite, LCM. Okay, or you cross multiply. So 2 times D plus small d plus 2 times T minus small d, all divided by D minus small d times D plus small d. It's just, we are through with the physics. We are doing math. So I simplify what I have. 2D plus 2 times small d plus 2D minus 2 times small d. Here, the denominator, I have difference of 2 squared. So D squared minus small d squared. I said we are through with the physics part. We are doing the maths. Okay. So when I simplify this and this cancels. So we have 1 on F. I hope you can see. Can you see? Or you are asleep?
You can see.
I thought you are asleep. Hey, Brittany Battels. Okay, so 1 on F. What this plus this would give us 4D on D squared minus small d squared. Brittany, mute yourself for me. Making F the subject, you have D squared minus small d squared over 4D. And this is This is the Brittany. Hello, Brittany. Mute yourself for me. I'm getting a very bitter feedback. This is the formula to find the focal length of the lens using the method of displacement. This method. Okay, so we know for power, determining the power will require the focal length. Okay, and this is what we will use to find the focal length of. Please, can I clean this side so we can write here? Can we?
Yes.
So the question gave us D. D is equal to 120. The question also gave us small d. This is 15. So the focal length F is equal to 120 squared minus 15 squared all over 4 times 120. And this is equal to 120 difference of 2 squared plus 15 times 120 minus 15, all divided by 4 times 120. Okay, so 135 times 105 divided by 4 by 120. Hilda. Yes, hail
Mr.
it.
Yeah.
Just hail this for me. If one die. Hail this for me. If one die. Somebody else.
29.53.
29.53
29.53.
centimeter. But the power of a lens is expressed in diopters. And to express the power of a lens in diopters, it means that the focal length must be expressed in meter. So we change 25 centimeter to meter, and we have to divide by 100. So 0.2953 meter. So that the power P is equal to 1 over 0.2953. And Hilda for me if Sawanaya. That is equal to 4
3.3863.
Give it to me. Give me in 3dp.
3.386.
6 diopter. And because this is a convex lens converges. And if the optical device converges, its power is expressed as positive. So plus 3.386 diopter. This is the power of the lens. Adwa Mponsa. So Naya ask question. Adwa, Akovala, Brittany, Deborah, Gloria, Hilda, Irene, and Anadwa. Any question?
No, please.
Then Gloria.
Mr. Adria.
Glory. Listen to the questions which follow. It says we are to find the first and second position of the lens for the formation of sharp image on the screen. This question is WASSCE 2023, but the second one I added to it. We have to find the position of the lens, the first position and the second position where a clear image is formed on the screen. Now look at how to find that. I don't want us to use that Hundius formula, but another way is this. You see, we earlier established that D is equal to okay, if this is U, okay, if this is U, this is 70, okay, or if this is U, then this side from this side is also U, and this is D. So we can deduce that D is equal to 2U plus small d. Look at it. If this is 30, this is 70. If from here to here is 70, this is 30. Are you following? I take it again. If this is 30, from here to here is 30. This is 70. Now, if from this point to this point is 70, this is 30. A different value. If this is 40, this is 60. If from here to here is 60, this is 40. So I can argue that this is from here to here is U, and from here to here is also U. So 2U plus small d must be equal to the distance between the illuminated object and the screen. Hence this. Okay. Now, if I make 2U the subject, I'm looking for U. 2U will be equal to D minus small d. Therefore, U is equal to D minus small d all on 2. So I have the first lens position, U1. And this can be calculated from D is 120. 120 minus 15 over 2. And U1 is equal to Hilda. Tell it for me.
52.5.
What?
52.5. 2.5.
So it means that this is the first position where a clear image can be formed on the screen. After obtaining the first position, all that I do is that I move this, displace this again to get the second position. So if U is this, and then the displacement is this, then the second position, which is this, U2, is simply U1 plus D. So it means that the second position will be equal to the first position plus the displacement, U1 plus D. Because I'm given the displacement, I have the displacement. So if I have the first position, adding the displacement to the first position will give me the second position where a clear image will be formed. Please, are you okay? Are you following?
Yes, please.
Okay, so once I know U1, 52.5 plus D, which is 15, would give me the second position of the lens where a clear image will be formed. And Hilda, hail it for me if so one now, yeah. 67.5, Hilda.
Yes, please.
67.5. Akofala, Brittany, Adu, are you there?
Yes, please.
Adu, are you there? Deborah, are you there? Irene too is here. You don't even cough. The rest of you don't even cough. Let's also use that's my formula. Okay. To solve the same question. Now, in my formula, we deduce that u will be equal to d plus or minus square root of d out, d in minus 4f all on 2. And I prove this with you. So this is the formula to determine where u1 will be, where u2 would be. D is equal to 120. We found the focal length of the lens f, and we got 29.53 centimeter. Here we are not using in meter because we haven't changed D. Okay. So if you use this, U would be equal to 120 plus or minus square root of 120 in times 120 out, bracket open, 120 in minus 4 times 29.53. Then you close the bracket, all divided by 2. So we have, Mamiado, are you there? Mamiadwa?
Mr. A, yeah.
Okay. So multiply 4 by 29.53. 4 times 29.53. Hilda. Hey, Gloria. Who is multiplying the
180.1.
118.12.
118?
0.12.
Okay, so subtract and then multiply by 120. Take the square root for me. So 120 minus 18 point blah 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 times this. Then you take the square root. So just give me the final thing. Deborah, are you doing it? Advance
67.5099.
for the final thing.
Yes, please.
Okay, I'm coming in. Let's confirm, please. Okay, so times 120, which is this. Then you take the square root of this. Oh, I had a I had 15.02. Please, let's confirm. Hilda, I was saying that subtract this from 120, whatever you get, multiply by 120 and take the square root of your results. Right?
Okay.
Then when you finish, U is this plus that. So either 120 plus, yes, 120 plus 15.02 divided by 2, or 120 minus 15.02 divided by 2. These are the two possible answers you have. So if you take 120 plus, there's it, divided by 2, you have 67.51 as this. So this first one is giving you 67.51 centimeter. Then the second one, when you subtract the same 120 minus 15.02, you have this. Then divided by 2, this is also 52.5. So, or 52.5 centimeter. So this is giving you the same values as you had. And this is the method of displacement. So it means when the two possible positions of the lenses where a clear image will be formed on the screen will be this and then that. Please, are you okay? Are we okay?
Yes.
All right. So I think we'll end here. Okay. But the solution, I'll upload it on the platform. So whoever needs it can review from there. Okay. So let's draw the curtains on our meetings. Okay, at this time, so we can get energy for tomorrow's activity. So until Tuesday, bye-bye. Good night to all of you. Okay.
Good night, Mr. Edia.
Okay.
Promise, Stadia.
Mm-hmm.
Stadia, please, is it possible you could put up the marking scheme as well?
Oh yes.
Okay.
I'll send a soft copy to whoever needs it. So you can send me a personal message and then request for it. Okay.
Yes, please. Thank you.
Welcome. Okay. Bye-bye then.